Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on behavior of electric dipole in a non-uniform electric field. Already we have done in uniform electric field that when dipole is placed, then equal and opposite force acts, as a result of which net force is zero. But torques act on dipole. Here in non-uniform field, force acting on charge minus Q placed at point A will be different from charge plus Q placed at point B. Why it is so? Because field is not uniform. Magnitude of field is different at points A and B. As a result of which, force acting on charge minus Q will be minus QE1 and force acting on plus Q charge will be QE2. This minus QE1 tells that this force is opposite to direction of electric field, and QE2 means this force F2 is in the direction of field E2. Basically, because magnitude of field is not same at these 2 points, field is not uniform. So opposite forces may act, but these will not be equal to each other. So net force will not be zero, It will be non-zero. And there will be torque on the system. Already in uniform external field, we found the value of torque, E sin theta. In that case, E was uniform. Field acting on charge minus Q and plus Q was same. So equal and opposite forces were acting at these points. But the density of this minus QE force was to align the dipole in direction opposite to field, and the density of QE force was to align this dipole in the direction of field. When this dipole is aligned along the field, there are two conditions. Either theta will be 0 or theta will be 180 degree. When I put value of theta here, torque will be 0 in both the cases. And this will be the system of equilibrium. When torque becomes 0, it is possible only if dipole moment is along the field, parallel to field or anti-parallel to field. Now, in this case, when field is not uniform, field is changing. I am taking increasing field from left to right. Forces acting on this dipole, charge minus Q and plus Q will not be same in magnitude. So net force will be in the direction of more force, which is acting on these two charges. We will find where more force is acting. Here on minus Q, less force is there. On plus Q, more force is there. Why it is so? Because field acting on minus Q will be less as compared to plus Q. Because I am taking increasing field from left to right. Now, here net force will be there. It will not be 0. Why it is so? Because forces are not equal in magnitude. So here net force will be in the direction of force acting on plus Q charge because it is greater in value. So what we find that here, this dipole moment is aligned parallel to electric field. Net torque will be 0, but net force will not be 0. There will be net force, and here net force is acting in the direction of increasing field. When P is anti-parallel to electric field, and electric field is not uniform, I am taking increasing field from left to right. So field E1 acting at charge plus Q will be less as compared to field acting on charge minus Q. And we can say E1 is less than E2. So force acting on plus Q charge will be lesser as compared to force acting on minus Q charge. So net force will not be 0. Although these forces are opposite, yet not equal because of non-uniform field. So force, net force will be in the direction of more force. That means because more force is acting on charge minus Q as compared to plus Q. And this force is from right to left. So net force will also be from right to left. it will be in the direction of decreasing field. So net torque is 0 because dipole moment is aligned parallel to electric field, because electric field is non-uniform. So there will be net force acting, and this net force will be in the direction of decreasing field. In general, the force depends upon orientation of dipole moment with respect to electric field. Now the question arises, a comb run through dry hair attracts pieces of paper. Comb, we know that acquires charge through friction, but paper is not charged. Then why paper bits are attracted towards comb? Basically, when we run comb through our dry hair, what happens? Due to friction electricity, comb is charged. Charges are induced. And what will happen then? There will be net dipole moment in the direction of field. But this field is not uniform. This non-uniform field will make dipole to experience a net force on it. As a result of which, paper will move towards comb. Thanks for watching this video. Like, share, subscribe my channel.